Hello, my name is Tommy Marrinan, and this is a demo of a CAVE2 application on planetary systems. In the middle of the cave, you will see a 3D representation of a single system's planetary orbits, and on the sides of the walls you will see multiple other planetary systems in 2D information to give you an overview and compare information between the two. In the 3D representation, I can fly through it and select objects, so here I click on Earth and get more information about it. Next, there is an interactive menu to change multiple features. The first one here is to be able to independently change the size of the planetary systems without changing the distance scale. So you'll notice that representation both changed the size in the 3D representation and in all the 2D representations on the wall. The second thing that just happened was changing the distance without changing the size. I can also interact with the 2D walls, which are completely configurable. So here I just can grab a 2D representation and move it to a desired location and swap their positions. The 2D representations are also used to select a new planetary system. So as I select on a new system, our solar system is replaced by the selected system, and you can navigate now in 3D space for that system. Now I'm just going to scale up the distance in order to get a better view of what is happening with this planetary system. The next thing I can do is sort the 2D systems based on certain criteria. So here I'm going to select the most stars, and as you see, every single panel repositions itself accordingly. Undesired panels can also be removed. This selected system is an interesting binary with two stars that are extremely close together. So here I really have to ramp up the distance scale all the way to 1 million before you actually see the separation between the stars. Also, they're rotating around each other extremely fast, so I slow down the timescale in order to watch them orbit. Another interesting multi-star system has an extremely large orbit. Therefore, I alter the camera speed in order to travel large distances in a short amount of time. Then, once reaching the system, I can scale back the camera speed down to a normal level in order to make finer movements. Here I also highlight the fact that I can select any object to bring up more information about it. Instead of just viewing one planetary system, I can view a star map of all the planetary systems. This shows the relative position of each planetary system as compared to the others. This view also highlights which systems are currently viewed on the 2D walls. Any name that is in red is a system on the 2D walls, any name that is in gray is a system not on the 2D walls. The last feature of this application is the ability to save and load configurations. Here I'm going to change the timescale and set up a specific orientation of the camera looking at a specific system. After that, I'm going to click the Save Load button and click Save. When I do so, you will notice that another file is added to the list of possible files to load. When I launch the application at a later time, I am then able to load these configurations. When I select the list, both the 2D and 3D representations all return to the state they were in when I clicked Save, and the system can be interacted with from that point. Loading up a different save file will demonstrate how I can save different configurations, which can be used to quickly highlight interesting findings. Thank you, and I hope you enjoyed this demonstration.